Oh yeah, welcome to this particular video. Alright, so this video is specifically meant for the science students in our midst. But if you're here just to learn, you're welcome. You're welcome. So today we'll be discussing a question on the dimension. So some students tend to find this dimension challenging. Yeah, kind of. But I will do justice to that in this video. Kindly pay rapt attention to it, right? Take notes when needed. To get at pause the video intermittently to solve before even looking at what step I'm to take next, right? It will help you to learn better, right, and be a better student. All right. So first of all, what do we understand, or what do you understand by dimension? What do you understand by magnetic flux? Yeah, I think that should be the first step. So what do you understand by magnetic flux? Okay, so magnetic flux is actually a measure of the amount of magnetic field passing through a surface, right? Passing through a surface. Okay, so what do you understand by magnetic field and the surface? All right, you see these green lines are the magnetic field. Do you understand that this part here is actually the surface in question, right? It's actually the surface in question. So we can just categorize this stuff here, right, as the magnetic flux. Is this clear? Now you have an overview of what magnetic flux looks like. Good. So before we solve any question on dimension, we must first get the formula. Know what the formula is. That's the first step. If you're asked to find the dimension of force, you don't just solve it that way. You first of all get the formula, right? There are certain cases where if you are very, very smart and good, you can just recall the SI unit and you're good to go. You get that, but just ensure you know the formula. Okay, for this now, this is the sign of magnetic flux, right? So it's equal to B A cos theta, right? So what does all this stuff, this what I wrote here, what does this signify? Before I proceed, I would like to draw your attention to the SI unit of magnetic flux in case you are asked in an external exam, right? In case you're asked in an external exam. So it's simple. The SI unit are Weber, which we can signify as WB, right? And Maxwell. Good. So I told you earlier that this sign here, right, is actually the magnetic flux. What of this? This is the magnetic field strength. This is the magnetic field strength. Right? This is magnetic field strength. What of the A? What does it signify? Correct. Area. Right? And cos theta is talking about the angle. Right. So which angle are we actually referring to in this case? Alright, so if you notice, there is an angle, right? This is not directly perpendicular. Like if this is a line and we have something like this, there is actually an angle here which is 90 degree. Do you get that? Sometimes the angle can be something like this, right? It can be as large as this, as small as this. Do you get this might probably be 30 degree or within that range, but lesser than 90 degree though. Do you understand? So this angle, which is actually between the surface of the object, do you understand, and the magnetic field, is actually the angle. Exactly, it's actually the angle. If you want to know more about this magnetic field or magnetic flux, kindly visit our YouTube channel, right? Subscribe to it, turn on the notification bell You get, so you can always receive updates whenever we post a video, right? So let's focus on what we have here now. So that means to say, before we can actually get the dimension of magnetic flux, we have to first find the dimension of magnetic field strength, and also the dimension of area, and lastly the dimension of cos theta. All right. Now, what's the dimension of magnetic field strength? Was it? I'm sure you'll be racking your brain by now. So we'll solve this together. What of area? What's the dimension of area? Area is what? Length times breadth, right? Right? Length times breadth, right? So the dimension of area is simple, which is what? Length squared. I get it. What of cos theta? What's the dimension of cos theta? It's dimensionless. So the dimension of, if you ask cos is if you ask the dimension of cos theta, just tell them what? 1 in an external exam, right? Probably in the US or India. All right. So the dimension of cos theta is basically what? 1, right? Generally all over the world. Okay. Now let's focus on, let's get the magnetic field strength, the dimension of magnetic field strength, and after that we impute it in our formula and get it straight without any hassle. All right, let's proceed. All right, so now what's the formula, or which formula links, what's the formula for magnetic field strength? Remember that the SI unit is Tesla. You know, there are several formulas. I get it. So now let's focus on one, which is what? Q VB is equal to F. Don't worry, I will explain everything to you, right? I will explain what each of them stands for. So this is the formula we're going to make use of to get our B, which is magnetic field strength. The Q here stands for charge, right? The V here stands for velocity, and our B, you know that already, right? So our F stands for Lorentz force. All right, good. So I think we're making progress now. Okay, so from here, what do? Make this surgical formula. Since we are looking for magnetic field strength, we have to make B subject of the formula. All right, so from here we get B is equal to F, which is our force, divided by charge times velocity. What's the dimension of force? Is ML, the dimension of force MLT minus 2. But in case you don't know, let's solve it really quick and then move on. So formula for force is what? MA. Do you get? Okay, so mass is set to, we know the dimension of mass already, which is what? M. Right? What is the area? Area is equal to velocity over time. Right? Velocity is equal to dimension over time. Right? So divided by t. Is that fair? Alright, so what's the dimension of displacement? L. Displacement is just a vector quantity, so it's literally or basically the same thing as distance. Do you get that? So don't confuse it. So time, the dimension of time is what? T. I get in this divide here, just take it here. Our dimension of t also, which is time, is also what? Capital letter T. Is that clear? Alright, so taking this, converting this division here into times, we'll take the t down, which will result into LT, right, times 1 over t, which is equal to LT squared, right? So if we are to make this linear, right, so that it will fit into our calculation, we will say what? LT minus 2. Take it out. So this stuff, we are taking it up. Is that clear? Alright, so now from here we've gotten the dimension of area, area of acceleration, and also the dimension of what? Mass. So that's how I came about what? MLT minus 2. Alright, what of this? The Q here, I told you, stands for charge. What's the formula for charge? Current times what? Try guessing it. Correct. Current times time. Alright, so what's the dimension of current? That's simple, everyone should know that. What's the dimension of time? I've said that over and over, which is t. So I've gotten the dimension of charge, we've gotten the dimension of force. Now let's focus on our velocity. Alright, so velocity, right, is equal to displacement over time. Exactly what I did here. Exactly. So which is what? L over t, which is also equal to LT minus 1. Right? So we're making progress. We found the dimension of everything. So now it's simple. Put everything into the formula and get what your B is. Alright? So now B, which is our magnetic field strength, is equal to our Lorentz force, or force, which is MLT minus 2 over Q, which is IT. This is just IT, sorry. So just IT, right? Put your dots, and LT minus 2. This is LT minus 1, sorry. Okay? LT minus 1. LT minus 1. Is that clear? Okay, so let's solve. Our L here our L in the denominator can cancel the one that is in the numerator. Our I, nothing to cancel. Our T, this and this. So it's simply this dot here simply means times. Do you understand? So it's not like, and times signifies multiplication or plus in indices. So we have 1 minus 1, which is what? 0. Do you get? So it simply means that these will cancelling each other. We're left with this, and this. So the dimension of magnetic field strength is equal to mi, or let me just put T so you don't get confused, then I. Whenever it wants to come up, the positive sign here will change to what? Negative. You know that it's an invisible one here. Right, so we'll now take it as what? Minus 1. So this is dimension of magnetic field strength. Alright, so let's go back to our formula. I told you that magnetic flux is equal to B A cos theta. Now, since cos theta is 1, we just put our 1 here. Our BA has been given already, which is MT, right? MT minus 2, I minus 1. Our A, let me take it here. This is for this. So let me take our A here, which is what? L squared. Is that clear? Is that clear? Good. So let's proceed. So take our M, just collect like them generally. Is there anything like L here? No, because we've cancelled every single one of them. So just take it together. We have M L square, right? That is this L square here. Then our T minus 2. Then our I minus 1. So this is our final answer. As simple as that, right? If you like the video, please share. Just share so that others can actually learn from it. Do you get? Share so that others can learn from it, and consider following us or subscribing. Thank you for being here. Right? So this is a solution to the question I dropped on all our platforms days before. Thank you so much.